All right, so this is lesson 641. It's on radians. And radians, as I mentioned before, are really unique. We derive information about radians from the circumference. And we know that the circumference is just the distance, the actual distance around the circle, right? The distance around the circle, that's talking about circumference. So radians are derived from ideas around the circumference. And also, the other concept for today is finding the arc length. So an arc length, if I have an entire circumference as my arc length, then in degrees we would call that 360 degrees. It would be 360 degrees all the way around. We'd use the circumference formula to find that arc length all the way around. If I was just going, still talking about degrees, halfway, right? Halfway around, that'd be 180 degrees. And we'd be able to find the arc length by taking the entire circumference and doing what with it? Dividing in two, right? We create a proportion. We create a proportion relating how much of the circumference we took, and whatever that measure of the arc length will follow that same ratio. So we're going to be dealing with proportions, proportions like this that we've been doing quite a bit. Two ratios that are similar or correspond to measurements in the other ratio, and then we cross multiply to work it out. So the actual what we do is mostly on this board, but I want to give you guys a little more conceptual background. The other kind of interesting part about radians is a radian measure can measure an angle, right? How far the angle opens, just like we usually use degrees, you can use radians. It could also measure an arc length. You can actually have a length that is a radian as well. So it's something different. It makes it, for Math 3, you're going to use radians a lot, especially when we get into trig. You're going to learn what the mode on your calculator is for a radian. But for today, we're basically just touching the surface. This is kind of an intro, one-up lesson. It's just going to get you ready for the whole month-long of trig you have next year. Okay. So where does 360 degrees come from? If you can guess this or know this, I'll go buy some more Starburst finally and give you one. Anybody ever thought about that? Yeah.
Okay, wasn't it like a square has 90-degree angles all around, and you can fit all the four corners of the square together and make a circle?
That's cool.
90
That's
times 4 is 60.
right. So that is an excellent proof using knowledge we know about squares. But then I would ask you, how do we know that a right angle is 90 degrees? It kind of goes to like, how do you know 1 + 1 = 2, right? It's like one of those real basic blocks. And that's where I'll bring up that the Babylonian civilization came up with degrees. And they decided to take a circle and break it into 360 different little segments. 360 different little segments. So we use degrees as a remnant of Babylonian math influence. So it is kind of arbitrary that all the way around a circle is 360 degrees. It's okay that it's arbitrary. It's still something that still works all the time. But that we use degrees more than radians is actually something kind of strange. It is kind of strange because a pure mathematician would say everything is in radians. We'll always use radians. We use degrees. We use a lot of things that are weird. I mean, we use inches. That's more, imperial versus metric is another debate. But as far as degrees versus radians go, radians are just an alternative to degree angle measurements. And it's actually the original. It's the one that is the pure mathematics is always in radians. Okay. Circumference we already know is pi r squared. And then I want you to think about this one. 1 radian is equal to an arc length of 1 over a radius of 1. That is too conceptual without a picture. But if I bring in the idea of the unit circle, which is something you'll see next year, what I can do is create a circle, and that's okay, with a radius 1 here, a radius 1 here, radius 1 here, radius 1 here. This is a sneak peek for next year. Okay. This isn't going to be something this is conceptual. We won't have a homework problem like this. But what I can see is, let's say I got this measurement out, and I'll say, well, this is going to be one measurement. This is going to be 1 unit. That much is 1 unit, right? When you have to figure out what a radian is, what the measurement would be of the angle, right? I'm going to have a radius of 1, and let's just say this is 1 unit. And then I'm going to have an arc length of 1. So I would go here and try to get that same unit, right, to about here. And it's not a perfect circle. So, you know, let's make it a little better than that. All right, but it's about here. Okay. So we have this arc length of 1. We have the radius, r equals 1. And for arc length, we're always going to start using s. So 1 radian, this degree theta here is 1 radian, is equal to this ratio of an arc length of 1 over a radius of 1. So that is how to derive the radian. You can see that as you add another radian, right? You're going to actually end up with almost 3 that make it halfway. Can somebody tell me why 3 radians don't make it all the way to the semicircle, all the way to this side over here, the half circle? Okay, let's think about this. So I'm going to kind of, let me throw one more hint out. That's great. The circumference of this circle with radius 1 is equal to what? Circumference equals 2 pi r. When the circumference for a radius of 1, what do we get? 2 pi. Radius is 1, the circumference all the way around is 2 pi. And that only works when you have a radius of 1, okay? So we can use a radius of 1 to figure out all these interesting things about trigonometry, unit circle, and whatnot. So if all the way around, when the unit circle's here of 1, all the way around is 2 pi, how far is halfway around?
1 pi.
1 pi. 1 pi. Okay. Now, what's really kind of tricky and interesting with this is, like I said, a radian can be an angle measure, or it can be an arc length, right? In this case, they are, when I have a radius of 1, this is pi radians, opening halfway. Pi is my measurement here, pi radians. This length, if this was a radius of 1, would also be an arc length of pi. Because radians can be an angle measurement, and it can also be an arc measurement. Okay. I'm sorry, I didn't give you a chance at all to, Ava, what were you going to say with why doesn't it get all the way down here?
I was going to say that it was pi.
It's pi? Good job. Sorry. I got going, I didn't stop. All right, that's really good. This is about as far as I want to go, but if you have a radius of 1, all these are radius of 1 radii, what you can do is you can deal with trig specifically much easier, because we're also going to learn next year that this is a point representing the x and the y values. When you bring sine and cosine into it, it matches up perfectly. It would be a whole lesson to show you how that matches up perfectly. But the unit circle is just something I want you to be acquainted with. It's for next year. Now you've seen it at least once. But the main thing from this I wanted to show is that a radian measurement can be an angle. A radian measurement can also be a length. Okay, an arc length. All right, so I'm going to put this aside for a second. An arc length, again, is just the length around the circle's edge based on the central angle. Whatever that central angle is, it's going to tell you how far along the edge of the circle you have to go. So this is all conceptual. This is hopefully giving you a little bit of grasp on the what we have to do. Yeah, time to go? Yeah. Alan, how about after the lesson? So the basics, though, for today are going to be converting between degrees and radians. So like I said, this is a lot of what I did front work here was for next year. For today, all we're asked to do is to get acquainted between going between degrees and radians, how they go between. So we already learned that if I go halfway, right? If I go halfway, it's 180 degrees. it's also pi radians, right? If I were to go all the way around, it'd be 360 degrees, or it'd be 2 pi radians, right? So we already have some relationships we can see. That halfway around the circle is pi, degrees and distance for a unit circle, and it's also 180 degrees. So we're going to use pretty much this proportion for everything we have to do when we're converting. Converting is right here. It's all for converting. Because remember, parts of this proportion have to correspond to each other. We know that in radians, pi, the angle measurement of pi, is equal to 180 degrees. So this is pretty much creating our ratios of relating radians to degrees, and we can count on this every single time to convert between 30 degrees and radians. Same exact formula to convert. So watch what I'm going to do here. I'm going to go ahead and set this exact thing up down here. We're looking for the radians, so I leave rad on top. Pi, I have 30, I have 180. You see how I just set that ratio up? Okay. I set up my two ratios equal to each other as a proportion. And then really, if you look at this, these are all number values. Pi is a number value. What is left that I need to find is my radian measure. So I'm going to find my radian measure. If this was x over 2, what would we do with 2? Instead of divide, we would do what? Multiply, right? So it's radian, some radian measure I'm looking for. This is like my x, radian, divided by pi. So instead of divide, multiply. I'm just going to multiply by pi. Cancels over there. And then 30 divided by 180. 80 times pi. You can use the pi button for most accurate option here. You get 0.524. So 30 degrees is equal to a radian measure of 0.524. Okay. What I said before as well was all related to a unit circle. We're going to have circles with different radius, different radii values. So just be ready for that. Everything is derived from the unit circle, but if the radius is larger, just like with vectors, it increases the magnitude, it increases how far out you go. So that'll become apparent next year when you get to more unit circle fun. But let's see what we have next. All right. So next we have a radian measure here, pi over 2. Pi over 2. So if I think about, go back to my unit circle, let's see if we can deductively figure this out. So everything always starts from right here. This is up here in quadrant 1. So let's see. Here's pi. Here's 0. Where would I find pi over 2? 90 degrees. Here. Pi over 2. If all the way to the other side, 180 degrees all the way semicircle gets us to pi, pi over 2 is just up here, right? So you can see that as this angle opens, in radians, as I open it up to get upright this direction, I'm to pi over 2, and then if it was degree measure, what would it be? 90 degrees, you see? So, yes?
Wouldn't 0 also be 2 pi, or would that be?
Good. Why is it 2 pi? Help us.
Because it's the circumference, right? So, right, because you multiply by 2.
Exactly. So, next year what you'll learn, that'll be like, it goes so far. It's really interesting how far you can go with radians and kind of redefining things. All the way around, yeah, the circumference is 2 pi, so this would be 0. It would, not as an ordered pair, but it would also be 2 pi. And then if I'm starting here, it always starts here in the first quadrant. And if I had negative pi over 2, what would that angle be? Negative pi over 2. Instead of going positive radians, going negative, and it would be right here. Right? So every measure also has a negative version of it as well. 0 is negative 2 pi, you can think of it that way. Okay. But what's neat is, as you get and find the same place, you can replace, instead of 2 pi, if it was 8 pi, you still find the measurements there for 2 pi, because it's that same spot no matter what. Okay. So it doesn't matter how many times you go around. Once you know the unit circle, you can amplify it. You can amplify it. You can change those values real easy. So let's go. Let's see if this actually works out for 90 degrees. Let's see. We're going to use this. The radians is pi over 2. Pi over 2 divided by pi is equal to the degrees, what we're looking for, over 180. The only variable thing I don't know here is degrees. All the rest here, these are values. Pi is just a number. Remember that. This right here, who looks at this and says, I don't know, I don't want to do that? Maybe a couple people silently in their head. What's this going to be when we reduce it? Anybody see that real quick?
Can it be 2?
How much?
Can it be 2? Or is that no?
Not quite 2. Let's do this one over here. I think we have to do it over here. Watch. Pi over 2 divided by pi, which is pi over 1. What are we going to do instead of divide? We're going to flip it, take the reciprocal of the second fraction, and then what happens to pi and pi? Cancel out. Every single time you access it through our conversion formula, it's going to cancel out the pi's. Every single time. This process is going to happen every single time. Okay? Every single time. So I know that I can work all this out and end up with 1/2, because there's a 1 and a 2, 1/2. Or I can just go right off the bat, and I know that's going to cancel. I end up with 1/2 is equal to the degrees over 180. Last step, get rid of that 180 by multiplying. 1/2 times 180 is 90 degrees. So we found it. It made sense from the unit circle. It makes sense here. Okay? So this is a very, this is like a method. When you convert, just use this right here. We're going to use this as our method to convert between them. Okay? All right. And you know what? I think that since these are so formula-dependent kind of methods here, it's just fine if you want to use this as like a map. Okay. So when I'm using, what I mean by that is, let's get rid of this. In this case, we're finding the arc length, right? Remember, the arc length is just how far we need to travel based on, let's make it that, based on my theta. So we're going to have some sort of theta. Actually, if I'm legit with this, it should be like that. We have some kind of theta, and we're going to have this arc measurement right here. The measure of, let's say this is AB. So I would do the measure of AB, just like so. So based on how far the angle opens and the radius, those two pieces of information will help me find this arc length. Okay. So there's two methods based on what you're given. Because, or next year I'll say you'll have different options because you'll be using degree mode for calculations. But for this year and just in this very introductory look at radians and arc lengths here, if you're given or you're looking for degrees, you're going to use this formula. If you're given or looking for radians, you're going to use our radian formula here. Okay. And this is really just, they're the same things. There's just a lot of manipulation to try to get them set up this way. So I don't mind us using these two as our main, think of it like a tool. Okay. So looking here, again, we have two corresponding values here. An entire circumference is how far around the circle? All the way around, right? 360 degrees is how far around the circle? All the way around. Okay. The arc length and the degrees are basically related because, just like I just drew and erased, the theta degree measure tells us how much of the arc length we're going to be looking for. So that's kind of how they are corresponding there. But what I'm going to do is kind of rely on this for a moment, and then I think it'll all come together. the arc length. If I'm trying to find the arc length, which is always going to be S, that's what I'm trying to find in this example problem. I'm going to go ahead and put S over C, which I'll find in a sec. Let's see, the diameter is 20 feet, central angle is 36, so I'm at 36, 360. Circumference is 2 pi r. Diameter is 20 feet. How much is the radius then? Yeah. So 10, 2 times 10 times pi. I'm going to have to go ahead and change this to be 25. Okay. Pi is a number. S is our only variable. We can solve from here by, let's just multiply by 25. 25 cancels over there. And S ends up being 0.1 times 25. Oh, that's just 2 pi. Interesting. One thing.
So the D was the diameter.
It is.
They gave you the diameter.
Correct.
That's a decent.
Yeah. We're not going to sweat that.
Okay.
We know we need the radius. Another way to look at it is the circumference is just pi times the diameter because you have 2 pi's here. Okay. But since we usually have radius measurements, they always give it to you this way. But 2 times the radius is 1 diameter. So if you really want to be sneaky, circumference could also just be diameter times pi. You could do it that way. I don't care. But this is the one we're going to see mostly. 6.28.
Where did the 2 go for the pi?
Where did the 2 go? Right here?
Yeah, the 2 pi r.
All right, think of it this one. 2 times r times pi. Same thing, right?
Okay.
Now I got 2 times r is the diameter, so I was just saying you could look at it that way, every way you want. All right, we got our arc length of 6.28. All right. Next, we're given radians, and this is back to the definition of what a radian is, because we know 1 radian is an arc length of 1 and radius of 1. 1 radian, or theta, our measurement of our radian, is S over R, the arc length divided by the radius. In this case, if we were looking from our definition, 1 radian is just a 1-to-1 ratio. So our number of radians is just based on this ratio. Again, given radians, or looking for radians, I use this one here. So let's go to it. Find S when radius is 3.8, central angle is 2.1 radians. Let's see. 2.1, that's my radian measure, is equal to arc length, S, when my radius is 3.8. If I just gave you this, if I wrote it earlier in the year, I guess I was using X more. But if I gave you that, everyone could do that. It's divided by 3.8, so I just multiply. So the actual, what you have to compute, as long as you get it in order and you know what you're given and which one to use, these relationships will all work. And you know how to do all this computation already. You're going to multiply by 3.8. Cancel, cancel. S is 7.98. Okay. Now everything over here was in radians. So this would be a radian. Actually, that is in radians. Yeah, this is in radians. So this would be a radian. This would be arc lengths in radians. This would be radian measurement here. And the reason why this isn't 2.1 radians, like why isn't the arc length 2.1? It's because the radius isn't 1. 1 radian, as far as an angle measurement, is equal to 1 radian arc length when we have a radius of 1. That just is only in our kind of basic unit circle example. Unit circle, 1. A unit circle is talking about when it's 1. Okay, let's see. Thumbs up, sideways, or down for this? Okay, great. Is it interesting and new? Who's seen this before? Anybody seen it before? Okay. Is it kind of crazy that you can have an angle measurement and also a length that are the same units? You see how it works out though, right? Yeah. Okay. Okay, guys, I want you to be able to do we have time to do all of them probably, but I want you to try to do numbers 1, 2, and 6 to start, because those are the 3 types of problems we have to do. Okay? Yes? Oh, all right. Okay. You're already working. One second. Yeah, close this up. All right, thanks for watching. Subscribe.